Hello, everyone. Oh, come on. Try that again. Hello, everyone. Good morning. Welcome. Happy to see you, 8:30 a.m., right after the parties of last night, which I missed. OK, we're going to start with a Mad Lib, and I'll need your help. So can we get how many of you guys have done Mad Libs before? OK, so the general idea is I ask for a type of word, and then you give it back to me. So adjective. Tall. Burly. I like burly. Medical diagnostic, like X-ray or mammogram or a CT scan. Adjective. Can you see me? No. OK. They usually give us a box for the short people. Adjective? What? Churlish. Sport? Racquetball. And one more. Contact sport. Curling. Human organ. Sport, we want to put in a gerund, like running or something. Boxing. UI interaction? Household appliance. Sorry? Espresso machine, OK. I think my hearing is only on one side. UI element? Ribbon. Do we have a ribbon? We have a ribbon. You second UI element. An accordion? Oh, an accordion control, right, OK. So you're going to have to help me. Hello, everyone. We're here today to talk about advanced profiling and performance techniques in Silverlight. And the first one is Silverlight 4 has profiling tools for your managed and user code, which is excellent. It has been something that has been requested for so long. And then the second thing is we're going to talk about the hardware pipelines. As far as I can see, there's not a lot of documentation about it. People are asking a lot of questions. And I get applications where they set cache mode everywhere, or they set cache mode nowhere. So I'm going to empower you guys to leverage the GPU in your application. So let's start it off. Writing a burly application or component in any platform is similar to keeping tabs on one's health. When you reach the point at which you are taking CT scans, it means that you could have just been a bit more churlish when playing either racquetball or curling. We can look at the system at different levels. We can monitor our brain, and while boxing, or our frame rate while double-clicking. We could find that we are more stressed when an espresso machine is running in the background, or if a ribbon is overlaying an accordion control. This morning, we will share the tools for diagnosing aspects of your application, and you will find that the best expert for actually making your application fast is you. So let's try that again with some more sensical words. So making your application fast is similar to like asking, why does my head hurt? Or what's going on with my blood sugar level? Most of the times, you could take a proactive stance on your medical health, or you could take a proactive stance on being more careful while playing racquetball or curling. You don't have to actually get to the X-ray before you realize that you could have done a better job of keeping tabs on your performance, translating back and forth. So profiling is similar to going to the doctor and asking for a little bit of help on how to make yourself healthier. And so we're going to start with 4 or 5 different tools that we have for measuring and profiling your application in different aspects. So the first step is generally to identify the problem area. If you're a patient, it would be like, my head hurts, or I can't see any longer. For Silverlight, it would be something like, what's the issue here? Are you concerned about the startup? Are you talking about the frame rate when you're scrolling? What do you mean by your application is slow? And then you want to actually monitor the changes as they come in. This is a proactive stance of medicine or of your profiling of your application. In the same way that you can either proactively keep tabs on your health or you can wait until you get a concussion. So the big thing for an example would be on frame rate, you want to make sure that the size of your dirty regions, the size that you're invalidating of your application every frame is quite small or as small as possible. And we'll try to do a good job, but it's also up to you to figure out how frequently we have to draw and how much we have to draw. And then, of course, I suggest always proactively testing on a range of hardware. So one of the first things that you can always do is to verify that things are as expected. The way to think about it is the user can see the application, but often the performance problems are somewhat hidden in the background. And you need a considerable number of tools to figure out what's going on. So one tool that we use is called UI Spy. How many of you guys have used UI Spy on some other .NET platform? OK. So UI Spy allows you to take a look inside the application and see what the visual tree looks like. So how many of you guys have used a virtualizing list box? OK, quite a few numbers. And how many of you guys have verified that it's actually virtualized? OK. So I built a list box the other day, and I thought that virtualization was broken. They said, no, 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 that's user error. So the first way that you can create a list box to virtualize it is to take an items collection and bind it to a list box. And so what happens is the items control generator will kick in and create a visual tree by applying the data template to each of the data items in that item source. So that's basically this model. So you have your list box. It's bound to an item source that's a static resource called names. Off screen, there you go. And then we have an item template that basically puts a stack panel with a button and 2 text blocks. And so what this happens behind the scene is the virtualizing stack panel says, because the virtualizing stack panel is the items panel in the default list box template, the virtualizing stack panel says, hey, items control generator, I don't actually need everything. Just give me the first top 10, and then you can be on your way. And items control generator says, OK, here you go. And so if you pop up UI Spy, which you have to run as an admin, let's see. And I click here, and I wait. And by the way, I'm in mode and hovering. So if I press Control and I click, then I see the UI tree of where I clicked. You'll see that we have all of the data items, but we only have the visual tree of the items that are visible. So you see that there are only so many items that have a visual tree, the first top 10. If I scroll down, virtualizing stack panel then says, hey, can you give me the next 10 items, but don't bother throwing away the visual tree. It's the same data template. Could you just reuse or container recycle the existing items? So if I can control click here, you'll see that the items on top are now virtualized, except for the ones that are not garbage collected yet. Ignore that. And we've reused these 10 items, and we've only built those 10 items that are visible now. And as I scroll, you can see that actually I have a pretty fast frame rate. It's a pretty smooth experience. We're doing all that container recycling behind the scenes. This is what I did when I first built my application. Is the other way to build a list box is to do something like explicitly create them in XAML. List box item, stack, panel, button, text block. So I explicitly created everything. And what's happening behind the scenes is the parser says, OK, I'm going to create this visual tree, and I'll just create these items too. And there are 100 items, and it generates them all. Notice that virtualizing stack panel isn't involved. Items control generator isn't involved either. So there's no virtualization happening. And the way to verify this is right here. So if I pick up UI Spy and I click on this control, we start off with only the list items that are visible. But if let's see, I'm going to page down because I can't see my scroll bar. You'll notice that we're creating the list items, the visual tree for all the list items that have been viewed thus far. And they never contain or recycle, and it never virtualizes. So the first trick for profiling is to make sure that you're actually getting the capabilities of the controls as expected. So verify that you're actually getting virtualization. Verify that you're actually getting data grid, and you'll be a little bit happier along the way. So your patient has walked in, and basically now you know its height and width of the tree. And so now you actually generally want to do a little bit of stress testing. You're going to do some little functionality. OK, we're going to go do a marathon, so let's measure our heart rate while we're running, or our speed while we're running. In the same way, you can also do the frame rate, the heartbeat of the application is called the frame rate. And Silverlight is a time-based system. And the best way to explain this is sort of like you have a film strip. And let's say that you're at the second frame. And our default is 60 frames per second, which translates to 33 milliseconds. So if I'm at the second frame, 33 milliseconds, and let's say I get busy for a while, the UI thread is doing something else, and I miss 3 frames. On a frame-based system, this would return at the third frame at 66 milliseconds. But in Silverlight's time-based model, you'll return at 132 milliseconds at the clock-based time. OK? So we evaluate at that point in time, where should the animation be? So sometimes you'll see what we call a stutter. It will be smooth, and then something happens in the background. User code kicks in, or we're downloading something and creating a big visual tree. It will stop, and then it will reappear on the other side of the screen. And the way to actually watch for stuttering of animations is to keep an eye on what's happening on the UI thread. And we'll talk about profilers in a second. But the first key is that in Silverlight, we have one UI thread, and we depend on the UI thread of the browser to actually do all of our user code, control code, layout, and animations. So how many of you guys are targeting IE6 or IE7? How many UI